carbutamide drug is having antibacterial activity, but it was found that it also having anti-diabetic activity, okay, as a side effect. So by removing that amino group by alkyl group, okay, so what happened, the functional group modification, after this functional group modification the antibacterial activity was eliminated, and whereas your anti-diabetic activity was retained by changing the functional group. Okay, so we are replacing that amino group with CH3 group, okay, that is called as tolbutamide. Okay, so the antibacterial activity was eliminated, and your anti-diabetic activity was retained. Okay, so again in the last lecture we had taken one example of this functional group modification, that is chlorothiazine. Okay, so this chlorothiazine, it is also called as aldocor. It is an antihypertensive agent. Okay, and it also has a strong diuretic effect. It also has a strong diuretic effect. Okay, and it was known for what this strong diuretic effect is due to the side chain. Is due to side chain. Okay, so that the by removing that side chain sulfonamide. Okay, so the this the after removing that drug, the after removing that side chain, it is called as hyperstat or dioxide. Okay, it was prepared, and that was a strong antihypertensive drug without having diuretic activity. Okay, so by eliminating the sulfonamide group, okay, we are removing the diuretic activity, and that drug purely used as a antihypertensive drug. That drug purely used as a antihypertensive drug. So again in the last lecture we had learned the structure activity relationship, that is SAR of sulfonamide. SAR of sulfonamide. So SAR of sulfonamide. Okay, so thus this sulfonamide, it was developed as an antibacterial agent. Okay, and it have following your SAR general, following the general structure that I had draw the general structure of that sulfonamide in the last lecture. Okay, again I am drawing that structure of sulfonamide. So it having benzene ring, H2, so the ring, SO2, R, and here is also your alkyl group is there. Or by modifying the increase the potency of a drug. Okay, learn is structure modification, potency, structure modification to increase the potency. Okay, so yeah, as you know that it is clear that the activity and the potency of a drug can be manipulated by modification of structure. Okay, so we have learned that SAR of sulfonamide. So it is clear that the activity, and the potency of a drug, can be manipulated by modification of its structure. Okay, this may involve the change in the nature, position of functional group, nature of the ring, length of the chain. Okay, so these are the modification that we can do. That is the position of, we can change the position of functional group, we can change the nature of the ring. Okay, to increase the potency, we can increase the length of chain. Okay, so in the extensive study of structure activity relationship, many standard molecular modification are developed to increase the potency, okay, and the therapeutic index. Some of the method of structural modification are discussed below. Okay, So there are many methods are available. Okay, so extensive study has been done on this structure activity relationship, and many standard methods are available to develop or to increase the potency of the drug. Okay, so out of that only two three methods we are standard method we are going to learn. Okay, so some of the methods are discussed, we are going to discuss here. Okay, so in that the first one is homolongation. Okay, the first one is homolongation. Okay, so homolongation. So now what is meant by homolongation? Okay, so the process of increasing chain length, the process of increasing chain length, it is called as homolongation. For example, you are going to increase the CH2 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 group. Okay, so the process of increasing the chain length, it is called as homolongation. Okay, so this homologous is a group of compound that differ by constant unit, generally CH2. Okay, so this homologous series, it is a group of compound that differ by constant unit, generally CH2 group. The biological properties of homologous compound shows the regularity of increase and decrease in it. Okay, so by increasing the chain length or decreasing the chain length, okay, the potency of that drug may be increases or decreases. Okay, so that is called as homolongation. The process of increasing chain length, it is called as homolongation. For many series of the compound, lengthening of a saturated carbon side chain from one methyl, okay, so from one methyl to 5 to 9, okay, that is pentyl to nonyl, okay, produce an increase in the pharmacological effect, but further lengthening result in the sudden decrease in the potency. Okay, so when we are going to increase the chain length, that is CH2 so from starting, first one is a methyl. Okay, then we are if we are going to increase that constant unit CH2 from 1 to 6, okay, that is your hexane and heptane. Okay, so the it was observed that the activity or the potency of the compound increases. Okay, then after that hexane and heptane, again if you are going to increase the CH2 group, the activity or the potency of that drug decreases, activity or the potency of that drug decreases. Okay, so so what the pharmacological effect, but the further lengthening result in the sudden decrease in the potentially. Okay, so initially the increase in the activity is due to what? Initially the pharmacological activity increases due to increase in the lipophilicity, due to increase in the lipophilicity of the molecule, which helps in the penetration into the cell membrane. Okay, so what, when you are going to increase the CH2 chain, okay, so that will increase the lipophilicity of the molecule. What, that will increase the lipophilicity of the molecule, and which helps that drug to penetrate into the cell membrane. Okay, that which helps to which helps to penetrate that drug into the cell membrane. Okay, but further increasing. Okay, when you are going to increase again the chain length after 8 carbon, okay, further increase in the chain length reduces the water solubility, that reduces the water solubility, which make it transportation to the aqueous medium difficult. Okay, so when you are going to increase the chain length, okay, it is difficult for the that drug may be insoluble, so water solubility is difficult, and the another reason is transportation through the aqueous medium is difficult. Okay, because your drug is insoluble in water, so it is impossible to transport that drug into aqueous medium. Okay, thus it reduces the activity of a drug. Okay, so let me show you that. Okay, so this is your first carbon, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10. Okay, so these are methyl, ethane, propane, butane, pentane, hexane, heptane, octane, none. Okay, so these are the your C chain length. Potency. Okay, so Okay, so you can see that. Okay, so at this carbon number 6, okay, hexane, okay, the activity is maximum, okay, when you are going to increase the chain length, okay, from 1 to 6 ethane, methane, propane, butane, like this, okay, the activity increases, okay, and activity is maximum at hexane, okay. Again, when you're going to increase the chain length, the activity decreases. You can say that the potency of the drug is decreases, okay. So the first, when you are going to increase the chain length, okay, the increase in potency, it is due to lipophilicity of the molecule, okay, which helps that drug to penetrate into the cell membrane, but further increasing, but what, from 6 to 10, 6 to 10, 6 to that is your hexane to decane, okay. What happen when you're going to increase the chain length, okay, its water solubility will decreases, okay, and it make transformation difficult through the aqueous medium, okay, and that reduces the activity of that drug, okay. So let's take one example of that. In case of aliphatic amine, that is the amine that having normal chain, what your aliphatic chain, not having a what, it having normal CH2 group, okay. So in case of aliphatic amine, the another problem is that micelle formation, okay. When you are going to increase the chain length, okay, aliphatic amine form micelle, okay. So this is the another problem of micelle, okay, that start from C12, okay, that start from C12, that is dodecane, okay. That is when you're going to increase the chain length from ethane, methane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, okay, no decane, dodecane, okay. So from dodecane, what uh, what, when you're going to increase the chain length after dodecane, okay, the problem is that that drug will form micelle formation, okay. So while investigating, take another example of this homologation, while investigating the hypnotic activity of alcohol, okay, while investigating the hypnotic activity of alcohol, okay. So alcohol having hypnotic activity, मला माहित असेल what some people are taking the alcohol, okay. So the after taking that, okay, they that people hypnotizes, okay. So alcohol having hypnotic activity. So while investigating the hypnotic activity of a alcohol, the maximum effect occurred at hexanol, 1 hexanol, okay, to octanol, okay. So while investigating the hypnotic activity, so if hypnotic activity is higher from hexanol to octanol, then the potency decline or the potency decreases on lengthening the chain until no activity was observed for hexadecanol, okay. So this your alcohol having good hypnotic activity from 1 to octanol, it having good activity from hexanol to octanol, okay. When you are going to increase the chain length, ethane, methane, propane, butane, pentane, hexane to octane, it having good hypnotic activity. Again, if we are going to increase the chain length, okay, up to hexadecanol, no activity was observed, hexadecanol don't shows or do not shows any hypnotic activity. So this is the what you can say that by what is the effect of your homologation when you are going to increase the chain length, okay. Initially the activity or the potency of the drug increases, then then suddenly it decreases, okay. So the reason is there, what due to solubility problem and transportation of that drug into the aqueous medium, so that make it difficult to show the desired activity to that drug. So this is your first point, okay, structure modification to increase the potency, okay, that is homologation. Then the second point is chain branching. The second point is chain branching. समझलं का रे? pH NH2, this is your phenylethylamine, pH CH2 CH2 is an excellent substrate for monoamine oxide. Okay, so it is excellent substrate for monoamine oxide, but alpha methyl phenylamine, okay, amphetamine, alpha methyl phenylamine amphetamine, it is a poor substrate, it is a poor substrate. Okay, alpha phenyl, because this alpha phenylamine, it is a branch, it is your you can say that it having branching chain, it having branching chain. So this alpha phenyl methylamine, okay, alpha phenyl methylamine amphetamine is the poor substrate for this monoamine oxide. Okay, so the branching chain having the problem for binding the receptor, okay, and the normal chain don't have any problem to bind with that receptor. So this is the normal chain. Okay, so this your phenylethamine having normal chain, so it can easily bind with the receptor, while your alpha phenyl methylamine, that is amphetamine, it is a poor substrate for monoamine oxide. Okay, now let's take another example. For example, the primary amine are often or more potent than secondary amine. So primary amine are more potent than secondary amine. So the compound drug having primary amine group that are more potent than the secondary amine, which are more potent than the tertiary amine. So secondary amine are more potent than tertiary amine. For example, the anti-malarial drug, that is primaquine. Okay, primaquine. So primaquine phosphate, it is much more potent than its secondary and tertiary amine analogs. That is tertiary, what your secondary and tertiary amine analog. So let me draw the structure of that. Okay, primaquine, and CH2, N CH3 CH, N CH3 CH3. Okay, so if this R is, okay, this type of chain, CH2 CH CH3 and CH3 CH3, okay, that is called as promethazine, anti spasmodic and anti histaminic activity predominates. Okay, so this is the name of the drug, this is your side chain and change in the pharmacological activity. Now the second side chain is side chain R, here chain R, here drug pharmacological activity, change in pharmacological activity. Okay, so this is the name of the drug. Side chain R and change in the pharmacological activity. Now second side chain is CH2, CH2, CH3, CH3 and CH3, CH3. Okay, so this is if this R is equal to CH2, CH2, CH2 and CH3, CH3. Okay, that is called as promazine. That is called as promazine. The name of that drug is promazine. CH2, CH3 and CH3, 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 CH3. Okay, this is side chain, and the name of that drug is trimiprazine, tranquilizing activity reduce and antipyretic, that is what is anti-itch activity increases. Antipyretic and it is also called as R. Then that drug is called as morphine, and if this R is CH, CH2, C6H5, C6